On September 7th, 2025, a total lunar eclipse occurs, bringing complete darkness. An object from another star system changed color from red to green. This event happened almost instantaneously and immediately. The rate of cyanide production spiked ninefold. Simultaneously, a large amount of industrial nickel was released without any presence of iron. Harvard University is monitoring it, as is the Pentagon, and in just 20 days, the object will disappear behind the sun. It is at this point that the alien technology could be disrupted. The object that returns in December may no longer be the same one that went in. Because right now, as you are listening to this, Atlas is ejecting 150 kilograms of material per second, yet its trajectory has not changed at all. This is mathematically impossible, unless the object weighs 33 billion tons, a mass over 1,000 times greater than any interstellar object we have ever observed. And this is what no one is mentioning. This object sent a radio signal from that very region of space 48 years ago, the WOW signal, with a random probability of only 0.6%. And then it appeared, perfectly aligned with our planetary orbital plane, with a probability of 0.2% and the timing of its passage by Mars, Venus, and Jupiter has a probability of just 0.005%. You do not just win the lottery 3 times by chance. On October 29th, the object will fall into shadow, hidden from all telescopes on Earth for 51 days. And when the U.S. government shut down NASA on October 1st, 2 days before the Mars flyby that would have given us the clearest images. Until now, the data has been buried. The high-rise, high-resolution camera, with a 30-kilometer resolution, it saw something, but we still do not know for sure. Harvard astrophysicist Avi Loeb gives a 30 to 40% probability that this is alien technology. The scientific mainstream calls him a madman, but the numbers do not lie. And the triggering event during that lunar eclipse was not the gradual warming of a comet, but a threshold, as if something was switched on. 3 observatories are now monitoring the skies for unidentified anomalous phenomena, or UAP has activity, because there is a theory that BAI Atlas is not the threat, but a diversion. While everyone is staring at the mothership, what is being deployed elsewhere? On October 19th, the 2 objects return for their closest approach to Earth. We are about to find out whether physics still works the way we think it does, or whether something else has been running this experiment all along. If you are as captivated by this mystery as I am, please like and subscribe, and let me know in the comments where you are listening from, and what time it is where you are, and whether you think BAI Atlas could become a danger to us, and if you would like to help our community grow, please share this video on X and Facebook, Reddit, or your messenger. Thank you for your continued support. Also, check out our merchandise linked below the video. We have some cool mugs and t-shirts that you are sure to love. This is the first of a 2-part video. We are taking a deep dive into BAI Atlas, analyzing what it is really trying to tell us. Then in part 2, we will cover all the latest scientific developments. You can use the timestamps to jump to any section you are most interested in. Chapter 1. The triggering event. The photos came in during the early hours of September 8th. Michael Jackson and Gerard Raymond, 2 astrophotographers working under the dark skies of Namibia, had been tracking BAI Atlas for weeks. They had chosen that particular night for a reason. A total lunar eclipse was underway overhead, which meant that the moon's usual light, that constant wash of reflected light that drowns out faint objects, would be extinguished for a brief period. The sky would be darker than it had been in months. They aimed their equipment at the constellation Sagittarius, to the region where BAI Atlas was supposed to be. What they captured was not what they expected. The object had changed color. Every previous observation, every spectral study done since the comet's discovery on July 1st, had shown the same thing BAI Atlas glowed a purplish red, the kind of color you would expect from an object covered in ancient, irradiated dust. Space has a way of turning things red over time. Cosmic rays bombard surfaces for millions of years, breaking down complex molecules into simpler compounds that are darker and redder. It is the rust of the universe. But the images from September 7th showed something else entirely. A bright, almost phosphorescent green color. Not a gradual transition. Not the slow transition of an object warming up. The color change seemed to be instantaneous, like a threshold had been crossed, as if someone had flipped a switch, right as darkness fell. Think about that for a moment. Comets do not work that way. As a comet approaches the sun, its surface warms gradually. Ice sublimates, gas escapes, and dust particles are lifted. This process is continuous and predictable. You can model it with fairly simple physics. Temperature rises. Volatiles escape. Brightness increases. It is a curve, not a step function. Atlas was not following that curve. The timing raised questions that were hard to ignore. Why would the transformation happen in total darkness? If this were simple heating from the sun, the color change should have been gradual, continuous, tied to the object's decreasing distance from the sun. Instead, it seemed to correlate with the lunar eclipse itself, with the removal of moonlight from the sky, as if the object had waited for observers to get the best possible view, or as if it had been waiting for something else. The green color itself tells a story. When astronomers see green in a comet, they usually know what they are looking at: dicarbon, a molecule made of two carbon atoms bonded together, that emits light at a specific wavelength that appears green to our eyes. It is a signature of organic chemistry, of carbon-rich ices being broken apart by sunlight. Comets like C2022E3, the green comet that passed through our solar system in 2023, glowed green because of the dicarbon in their atmospheres. But spectral observations of Atlas did not detect dicarbon, at least, not yet. The instruments pointed at this object should have seen that telltale emission line, but they did not. So, what was making it green? Avi, the Harvard astrophysicist who has become both famous and controversial for his willingness to consider unconventional explanations, suggested an alternative on August 25, 2025 cyanide. The Very Large Telescope, VLT, in Chile's Atacama Desert had detected something unusual in the atmosphere surrounding Atlas. Cyanide, specifically the CN molecule, was being produced at a rate of about 20 grams per second. That, in itself, is not particularly strange. Comets can produce cyanide. It is part of their complex chemistry. Occurs when organic-rich ice encounters solar radiation. But the strange thing was what happened next. As Atlas moved closer to the sun, the production of cyanide didn't just increase, it surged. The production rate increased with the inverse of the heliocentric distance raised to the power of 9, plus or minus 1. For those less familiar with mathematical relationships, that is an extremely steep increase. Most cometary outgassing follows gentler power laws, usually between 2 and 4. 9 is off the charts. That's the kind of exponential spike you would expect from a chemical reaction reaching a critical threshold, not from the gradual warming of ice. And cyanide, unlike dicarbon, can produce a green glow under the right conditions. If the concentration is high enough, if the excitation mechanism is right, you get a green glow. The wavelength isn't quite the same as the carbon signature, but to a broadband camera, it would look similar. But this is where the story gets stranger. Cyanide wasn't the only thing that spiked. Nickel did as well. Data from the Very Large Telescope showed nickel emission increasing at a similarly dramatic rate, about 5 grams per second, rising as the object approached the sun. Nickel in a comet's atmosphere is not unheard of. Many comets carry trace metals. As solar radiation heats the surface, these metals can be released as vapor, glowing at characteristic wavelengths as they absorb and re-emit light. The problem was what was missing. Nickel and iron are siblings in the cosmic abundance table. Cosmic abundance table. They form together in the cores of stars, are ejected together in supernova, and condense together in planetary systems. Wherever you find nickel in natural space objects, you also find iron. The ratio varies, but both are always present. It's one of the most reliable patterns in astrophysics, like finding hydrogen wherever you find stars. And Atlas was ejecting nickel without any detectable iron. The research team in Chile noted this in their paper, published in late August, where they measured the nickel emission. Obviously, they looked for iron using the same instruments and methods. But no, this ratio was skewed to an incomprehensible degree within the framework of natural cometary composition. Lepp had pointed out something that made the scientific community uncomfortable. There is one place where you often see nickel without iron industrial manufacturing, specifically nickel carbonyl, a process used in metallurgy to produce high-purity nickel, and heating nickel ore in the presence of carbon monoxide forms nickel tetracarbonyl, a volatile compound, which is then decomposed to retrieve pure nickel metal. That is how we create nickel for alloys, batteries, and specialized equipment. That is not how comets create nickel. The suggestion was clear, even if Lepp phrased it as a question. Could this anomaly be further evidence of Comet Atlas's possible technological origin? Were we looking at industrial chemistry happening in space? Most astronomers dismiss this immediately. The peer review process, the careful consideration of evidence, all pointed towards natural explanations. Perhaps the iron was there, but bound up in dust particles that did not emit light in the same way. Perhaps the surface composition was unusual, enriched with nickel-bearing minerals through some quirk of formation. Perhaps the measurement was wrong, or the interpretation was incorrect. Perhaps, but the timing of the green activation, the threshold-like behavior, the industrial chemical signature, they all came together in a way that was difficult to completely dismiss. Each individual piece could be explained away, but together they formed a pattern. And there was one more detail that made the activation event particularly intriguing. The brightness data published by the Atlas telescope team, using observations dating back to March 28, 2025, revealed something surprising about how Comet Atlas had been behaving when the object was further from the Sun than 3.3 astronomical units, farther than the distance between the Sun and the asteroid belt. Its brightness increased in a specific way, the cross-section of scattered light. The amount of sunlight the object was reflecting increased with the inverse of the heliocentric distance to the power of 3.9. Then, something changed as it got closer. The rate of increase shifted. The relationship broke down. Instead of continuing to brighten at the same rate, the object's behavior changed, as if another process had taken over. Researchers have suggested a physical mechanism where when Bi-Atlas is far from the Sun, it primarily scatters light from its reddish-purple dusty surface as it moves closer. It begins to release small, bright ice particles, which increases the reflectivity of its surrounding atmosphere. The transition from one mode to the other would naturally cause a change in how its brightness scales with distance, which is a plausible explanation. It fits with known physics, but it also means that Bi-Atlas underwent a transition, a change in its physical state, at a specific distance from the Sun. Not gradually, not smoothly, it switched modes. The triggering event during the lunar eclipse could have been part of that transition, or it could have been something else entirely. We are left with images showing a dramatic color change, chemical signatures that do not fit standard comet models, and a light curve that shows the object is reacting to the Sun's heating in ways we have never seen before. 7/9 is night. We cannot explain Bi-Atlas by using simple analogies with other comets. Something about this object is different, whether that difference is natural or artificial. Whether it is a quirk of unusual chemistry or evidence of technology remains an open question, but the activation happened. The images exist. The spectral data is real, and within the community of astronomers monitoring this object, a simmering unease is spreading, because if by Atlas is just a comet, then it is a comet that breaks the rules. And if it is not a comet, if there is that small chance that it is something else, then we need to start asking very different questions about what will happen when it disappears behind the sun in October. Questions like, will it come back the same as it was? Chapter 2. The Decoy Hypothesis. There is a hypothesis circulating among a small group of researchers that no one wants to say out loud in official channels. It comes from Oma El Daddy, one of Avi Loeb's collaborators, and it's the kind of idea that sounds like science fiction. Until you start to look at the timing, the hypothesis is simple. By Atlas is not a threat. It is a distraction. Think about how you would design a reconnaissance mission to a planetary system you have never visited. You wouldn't announce your presence. You wouldn't make a direct approach to the inhabited world. You would want to observe without being observed, to gather data while remaining hidden. But there is a problem. Any civilization advanced enough to detect objects in space will eventually detect your probe. Telescopes improve. Survey systems get better. Eventually, you will be found. So what do? You send something obvious, something large, bright, and impossible to miss, something that will consume the attention of every telescope, every observatory, every planetary defense system, while they are all tracking the obvious object, while they are debating whether it is natural or artificial, while they are writing papers and holding press conferences. Your real mission takes place elsewhere, unnoticed, untracked. The decoy draws the eye. The real work happens in the shadows. Loeb proposed this in a conversation with Lepp, framed as a thought experiment. But thought experiments have a way of becoming hypotheses when the data starts to fit too well, and the data around BY Atlas fits uncomfortably well. Consider the object's behavior. It is very large, much larger than it needs to be. It is bright, easily visible with ground-based telescopes. It is moving on a trajectory that brings it close to multiple planets, ensuring maximum observation time. It exhibits anomalies, strange chemical signatures, unusual brightness patterns, all of which generate discussion and analysis and focused attention. It is almost perfectly designed to be noticed. But if you are trying to distract the astronomical infrastructure of an entire civilization, you need more than just an interesting object. You need timing. You need the object to arrive at a time when it will cause maximum focus, maximum resource allocation, maximum debate. By Atlas was discovered on July 1st, 2025. Within 24 hours, it was confirmed to be interstellar. By July 3rd, major observatories around the world had been redirected. Their instruments. The Hubble Space Telescope photographed it on July 21st. The James Webb Space Telescope observed it on August 6th, and SFOREX collected data from August 8th to the 12th. The Very Large Telescope in Chile performed spectroscopy on August 25th. Every major astronomical facility, every space telescope, every planetary defense system capable of tracking fast-moving objects, all were watching the Atlas flyby. Hundreds of millions of dollars of equipment, thousands of hours of observation. The focused attention of the global astronomical community, all directed at a single object. So the question becomes, what are we not looking at? Loeb took his proposal seriously enough to implement an actual monitoring program, the Galileo Project, which he founded in Leeds, operating 3 observatories, one in Massachusetts, one in Pennsylvania, and one in Nevada, unlike traditional astronomical observatories, which focus on distant objects. These facilities monitor the entire sky continuously. They are designed to detect objects, moving quickly in Earth's atmosphere and near-Earth space, unidentified aerial phenomena, in the careful language of government reports, or UFOs in the language everyone understands. The Galileo Project's observatories use sensor arrays, infrared cameras, optical cameras, radio detectors, audio sensors, and magnetometers. They record everything, building a continuous movie of the sky. When something unusual appears, when something moves in ways inconsistent with known aircraft, satellites, or meteors, the system flags it, the data is analyzed, and patterns emerge. Loeb gave his team a specific task: monitor UAP activity during the Atlas flyby's perihelion passage. Look for correlations. See if anything else appears in Earth's atmosphere or near-Earth space. While the astronomical community is focused on this interstellar visitor, the monitoring window was specific. October 31st, 2025, when the Atlas flyby reaches its closest point to the Sun. That is when the object would be most active, at its most energetic, most capable of doing whatever it was about to do. And that's when, if the decoy hypothesis is correct, whatever else was happening would go unobserved. The reasoning behind this enters uncomfortable territory. If an advanced civilization wanted to deploy probes into our solar system, how would they do it? You wouldn't launch them from your home star system and hope they arrive intact billions of years later. Interstellar space is harsh radiation, micrometeoroids, the slow decay of any mechanical system. Even the most robust probe would degrade over that time. Instead, you would send a mothership, something large enough to carry multiple smaller probes, equipped with the power and propulsion to make the journey. When you arrive at the target system, you don't just do a single flyby, you decelerate. You enter a bound orbit around the host star. Then you deploy your probes, sending them to the places you want to study: Earth, Mars, Venus, the asteroid belt, the moons of Jupiter, anywhere that might harbor life or resources or interesting phenomena. A mothership entering our solar system at the speed of Comet Atlas, about 60 kilometers per second relative to the Sun, would need to brake hard. The most efficient place to do that is at perihelion, its closest approach to the Sun. Using what's known as an Oberth maneuver, you fire your engines when you're moving fastest, when you're deep in the Sun's gravity well. The physics of orbital mechanics means you get more delta V, more change in velocity for the same amount of fuel. This is the optimal strategy for an interstellar spacecraft trying to enter a bound orbit. Comet Atlas reached perihelion on October 29th, behind the Sun, hidden from all telescopes on Earth. If it performed a braking maneuver, we wouldn't have seen it happen. And if it released smaller probes during that period of concealment, sending them on trajectories toward the inner planets, we wouldn't have seen that either. Not right away. The probes would be small, dark, traveling on carefully calculated paths designed to minimize the risk of detection. They would arrive at their destinations weeks or months later, long after Comet Atlas had moved on. By the time we realized there was something else in the solar system, it might be too late to do anything about it. This is where the decoy hypothesis shifts from uncomfortable speculation to a genuine concern, because there is a number that makes this scenario more plausible than it should be: 85. That is the approximate time it would take an object moving at the speed of BAI Atlas to travel from a base located 1,000 astronomical units away. 1,000 times the Sun-Earth distance to reach the inner solar system. 1,000 astronomical units is far, but not impossibly far. It is within the furthest reaches of the Oort cloud, the vast, icy sphere that surrounds our solar system. An advanced civilization could establish a base there, hidden among billions of frozen comets and asteroids, and we would never know it existed. Our best telescopes can detect large objects out to their furthest reach, about 10 times the Sun-Earth distance, perhaps 20 if we are lucky and the object is bright. Beyond that, space becomes completely dark to us. We cannot see what is lurking in the outer solar system. We assume it is just comets, ice, and empty space. But that is an assumption based on a lack of data, not on comprehensive surveys. What if there is a base out there, a station, an outpost, or a way station placed by a civilization that knows how to navigate interstellar space? They could have been watching us for centuries, monitoring our development, waiting until we reached a certain technological threshold, and then sent something in. BAI Atlas could have been launched 85 years ago, in 1945, right around the time humans first split the atom, right around the time we developed the capability for planetary-scale self-destruction. That is the kind of threshold that might trigger a response from observers. If such observers exist, all of this might just be paranoid speculation and pattern matching on coincidences, seeing design where there is only chaos. But the instruments of the Galileo project are still recording relentlessly. The monitoring of the skies continues, watching for any increased UAP activity in late October. If objects begin appearing in Earth's atmosphere, inconsistent with conventional explanations, the data will show it. Sensors don't care about hypotheses or biases. They just record what is there. And that is what makes the decoy hypothesis testable, at least in part. If BAI Atlas is just a comet, UAP activity will remain at baseline random events, misidentifications, the usual noise in the data. But if something else is happening, if the diversion theory has any merit, the statistics will shift to be more anomalous, tighter temporal clustering, patterns that correlate with BAI Atlas's perihelion. We won't have to wait long to find out. The monitoring is happening right now. Data accumulates every night. By the time BAI Atlas emerges from behind the sun in December, we will know if anything has changed in our skies. While we are tracking the bright object that everyone can see, the uncomfortable truth is that we are not equipped to detect a sophisticated deception. If an advanced intelligence wanted to observe us secretly, while we are distracted by an obvious target, we don't have the sensor coverage or analytical capability to catch it. We can barely track near-Earth asteroids that might pose an impact threat. Detecting stealth probes operating in Earth orbit would require infrastructure we haven't built. This raises a question, one that keeps some researchers up at night. If the decoy hypothesis is correct, if there is a mothership behind the sun preparing to deploy precision probes throughout the inner solar system, what exactly are we supposed to do about it? The answer right now is nothing. We watch, we record, we hope that whatever happens next is benign or non-existent, because we are not ready for anything else. Chapter 3. The Non-Random Shutdown Event. 1 of 10. 2025. The U.S. government shuts down. Over 15,000 NASA employees are furloughed. Offices close. Data feeds freeze. Communication channels go silent. 2 days later, BAI Atlas makes its closest approach to Mars. The timing is notable. NASA's Mars Reconnaissance Orbiter, MRO, carries a camera called HiRISE, the High-Resolution Imaging Science Experiment, which is designed to photograph the Martian surface in extraordinary detail, capturing features as small as 30 centimeters from orbit. But cameras are indifferent to what they are pointed at. If you point HiRISE toward deep space, toward a fast-moving object passing Mars, the resolution translates differently, 30 kilometers per pixel. That is enough to potentially resolve the nucleus of BAI Atlas, to see if it is a single solid object or something more complex, to detect structural features if they exist. HiRISE took images on October 2nd and 3rd. The camera operators knew the schedule. They had planned the observation for weeks. The data was collected, stored, ready to be processed and released. Then the government shut down, and the data remained locked inside NASA's servers. Stephen Miller, the White House Deputy Chief of Staff for Policy, gave an interview on October 3rd, a portion of which was broadcast on national television. He was asked a direct question. Has the president been briefed on TUI Atlas? The question was not random. It came from a journalist who had been following the story, who knew about Webb's papers, who understood that an interstellar object exhibiting anomalous properties might warrant executive attention, the kind of thing that would normally trigger classified briefings, contingency plans, and interagency coordination. Miller's response was cautious, non-committal. He acknowledged awareness of the object but refused to confirm or deny any presidential briefings. Standard procedure, when you do not want to discuss classified information in public. But the fact that the question was asked, the fact that it made it through editorial review and onto national television, suggests that someone in the chain of communication thought it was worth pursuing. The timing becomes unsettling when you look at the chain of events. The shutdown began on October 1st. The Mars flyby occurred on October 3rd, and on October 4th, just 24 hours after the closest approach. Several mainstream media outlets received preliminary briefings from NASA sources, stating that Atlas was a normal comet. No technical reports, no images, no spectral data, just verbal assurances that everything was normal. Nothing to see here, move along. NASA's official position was that processing high-resolution data takes time. The images needed calibration. The team needed to analyze what they were seeing before releasing anything to the public. This was standard procedure. Releasing uncalibrated data prematurely could lead to misinterpretation, false conclusions, and unnecessary panic. All of that was true. It was also true that rushing out a verbal description before the analysis was complete seemed inconsistent. With the careful approach NASA usually takes, if the data required days or weeks of processing before it could be properly interpreted, why give a summary briefing to the news agencies 24 hours after collection? Why not wait until the full analysis was complete? Lass's response to questions about the shutdown was blunt. When people asked him if the delay in releasing the data might indicate a conspiracy to hide evidence of extraterrestrial intelligence, his reply became a quotable soundbite. The delay is not a sign of extraterrestrial intelligence. It's more like a sign of terrestrial stupidity. It was a good line. It framed the situation as administrative incompetence rather than malicious intent. And administrative incompetence was certainly the simpler explanation. The one that required fewer assumptions. The one that fit with Occam's razor. But timing is a stubborn thing. It doesn't care about simplicity or elegance. It just sits there in the data, refusing to be ignored. The European Space Agency, ESA, had not faced a shutdown. Their Mars orbiters, the ExoMars Trace Gas Orbiter and the Mars Express, had both imaged BAI Atlas on October 3rd. ESA released those images on October 7th, a 4-day turnaround. This was reasonable for an unexpected target, using instruments designed for surface imaging. The images showed a fuzzy white dot against the blackness of space. Not much detail. The cameras were not optimized for observing distant objects, but they released what they had, raw, preliminary, and uncalibrated. This is what we saw. Judge for yourself. NASA's approach was different. Silence throughout the shutdown. Verbal briefings for select agencies, describing the object without showing the data. Then continued silence on the high-resolution observations, which should have provided significantly better resolution than anything ESA had captured. The Chinese Space Agency operates Tianwen-1, another Mars orbiter with imaging capabilities. The United Arab Emirates operates the Hope Orbiter. Both were in position to observe by Atlas. Neither has released public data, whether they captured useful images, whether they are analyzing what they found, whether they are sharing that analysis with other agencies. All of that remains unknown. Radio silence is sometimes a choice. Sometimes it is procedure. And sometimes it is the sound of people trying to figure out what they are looking at before they tell anyone else. There is a pattern in how governments handle information that does not fit existing frameworks. First, confusion, then classification, Then a careful trickle of sanitized details, designed to manage the public response. That is not necessarily malicious. It is the institutional immune system protecting itself from chaos. If by Atlas were just a comet, if the data showed nothing unexpected, then the delay would be meaningless. Processing takes time. The shutdown caused disruptions. Everything would eventually be released, and it would all make sense. But if the data showed something not easily explained, if high-rise captured images that raised more questions than answers, then the silence becomes strategic. You do not release confusing information during a government shutdown. When you cannot provide the proper context, cannot coordinate messaging between agencies, cannot prepare the scientific community for what they are about to see, you wait, you analyze, you build a consensus, and then you release it in a controlled way, designed to minimize disruption. Or you never release it, and you let everyone assume that the data was unremarkable. Amateur astronomers tried to fill the gap. A YouTuber operating under the name Dabsonian Power posted images taken on the 3rd of October, claiming to show unusual structural features in BA Atlas. The images spread rapidly on social media. Thousands of shares, hundreds of comments. Was this the evidence of an artificial structure? Was this the proof we had been waiting for? Analysis by other astronomers poured cold water on the excitement. The images were taken with solar observation equipment, not a deep space imaging instrument. Aggressive digital enhancement had amplified noise into apparent structures. Atmospheric turbulence, optical aberrations, processing artifacts, all combined to create patterns that looked meaningful but were not. It was a reminder that we crave clarity. We want answers. We want high-resolution images to show us definitively what this object is. And in the absence of official data, we will accept amateur observations, wishful thinking, anything that fills the void. The void exists because the people with the best instruments, the ones who actually have the data we need, are not sharing it. Whether it's due to incompetence or intention, the effect is the same: uncertainty, speculation, a growing sense of unease. What did High-Rise see? The camera has the resolution to potentially answer fundamental questions about BA Atlas. Is it a single, solid nucleus or a loose aggregate? Does it show surface features consistent with natural formation or something else? Are there any geometric structures? Any signs of components inconsistent with a rubble pile model? Those images exist somewhere in NASA's data systems. The raw files are archived. The photons from BA Atlas have hit their detectors. The information has been recorded. The answers to at least some of our questions are sitting in a database, waiting to be processed and released. Days passed, then weeks. The government shutdown ended. Operations resumed. And still, there were no high-rise images of BA Atlas appearing in the public archive. You can check the high-rise group, which maintains a database of all observations. You can search by date, by target, by coordinates. The observations from October 2nd and 3rd should be there. They are not, or they are not tagged in a way that is easy to find, or they are undergoing prolonged processing for unexplained reasons. Radio silence from the highest resolution camera that had a clear view of the most interesting interstellar object to visit our solar system in years. Perhaps it is nothing. Perhaps the bureaucracy is just slow. Perhaps we will eventually see the images, and they will show exactly what we expect: a slightly unusual cometary nucleus surrounded by a dusty coma. Nothing unusual. Case closed. Or perhaps the silence itself is the signal, not evidence of a conspiracy, but evidence of confusion. People are trying to understand what they are looking at before they show the whole world. Scientists argue over interpretations. Administrators weigh the risks of releasing data that could be misunderstood. The shutdown gave everyone an excuse for the delay. To blame the politicians. To blame the budget crisis. Do not blame the astronomers, who are just trying to do their jobs. But the shutdown did not stop the ESA from publishing their images. It did not stop amateur astronomers from posting their observations. It only stopped NASA, the agency with the best data, from sharing what they found. And that absence spoke volumes more than any official statement could. Chapter 4. The Scientific Civil War. Jason Wright sat in his office at the University of Pennsylvania, a senior astronomer with credentials that could not be easily dismissed. He ran a blog called Astro Wright, where he discussed his research, commented on papers, and engaged with the broader astronomical community. In late July 2025, he wrote a post titled AV and BA in Atlas. The post was not kind. Wright went through Webb's analysis point by point, methodically breaking down the arguments about image blurring, the atmospheric detection, and the spectroscopic data. He pointed out what he saw as fundamental misunderstandings of how astronomical observations work. The tone was one of exasperation, the kind of frustration that comes from watching someone with a large platform, making claims that do not hold up under scrutiny. In one particular section that stands out, Wright quotes from Loeb's preprint paper, the statement that the fuzziness observed around Atlas was inconclusive, due to the object's motion and the unavoidable blurring of its image during the exposure time. Wright then explains why that is wrong. Comet astronomers do not track the stars. When observing a comet, they track the comet. The telescope follows the object across the sky, keeping it in the center of the frame. The stars get blurred. The comet stays sharp. It is a basic technique, the kind of thing any planetary scientist learns in graduate school. Loeb had dismissed the observations of Atlas's atmosphere by claiming they were artifacts of a tracking error. But the observers did not make a tracking error. They were doing their jobs correctly. The atmosphere was real. Wright's conclusion was blunt. This was sloppy work, below the level of an undergraduate student. He then assigned it a grade. The blog post included an actual report card filled out as if Loeb had turned in a homework assignment. The final grade was a fail. That is not how scientific disagreements normally play out. Researchers write response papers. They present counter-evidence at conferences. They engage through official channels, maintaining professional courtesy, even when they think a colleague is profoundly wrong. You do not publicly grade another scientist's work as if they were a student who had not studied for a test, unless you have reached a point where professional courtesy seems less important than stopping misinformation from spreading, unless you think the normal channels are not working, that the careful process of peer review and academic discourse is being bypassed by blog posts and media interviews. And someone needs to state plainly that the emperor has no clothes. Wright was not alone. Other astronomers, those who work with comets, asteroids, and interstellar objects expressed similar frustrations. Most did so privately. Some did so in workshops and scientific meetings. A few were willing to speak publicly to journalists, though usually with great caution. It is unusual. It does not fit the standard models. But it is probably natural. We need more data. The word probably carries a great deal of weight in those sentences. Something almost none of them would say publicly. Something you only hear in private conversations, over coffee or late at night at conferences. Is that to engage with Loeb's theories? Is to provide them with oxygen? The more they are discussed, the more they are debated. The more attention the ideas receive. The controversy becomes the story, and media outlets love conflict. Harvard professor claims alien mothership versus mainstream scientists, who say it is just a comet. That is a clickbait headline. So, most astronomers chose silence, not because they agreed, not because they could not refute the claims, but because the publicity amplifies the original message. It is a trap. By engaging, you spread the idea to a wider audience. Ignore it, and the idea spreads anyway. But at least you are not helping it. This creates a vacuum. The public hears one articulate voice, a credentialed one, saying extraordinary things. They hear a few rebuttals, often technical and difficult to understand. And they hear a great deal of silence from the people who should have opinions but will not share them. Into that vacuum flows speculation, conspiracy thinking, the assumption that silence equals suppression. Steve Desch, an astrophysicist at Arizona State University, broke the silence in another way. He did not write a blog post. He graded the paper on social media, showing that his calculations were wrong. Sorry it took so long to grade your August 20th homework assignment. Loeb, are you sure you're ready for a class on comets? You might need to learn about things like bow shocks and chemistry. The taunt was direct. Desch had spent his career studying how planetary systems form, how objects in space behave, how to interpret the data we gather. When someone with a background like Loeb's makes claims that contradict fundamental physics, claims that require ignoring well-established processes, the frustration becomes personal. Because it is not just about being wrong. Everyone is wrong sometimes. Science progresses through corrected mistakes, through hypotheses that are tested and discarded. The problem is what happens when someone influential keeps making the same kind of mistake, refuses to engage with technical rebuttals, and continues to promote ideas that the broader community considers deeply flawed. Tom Statler works at NASA as the lead scientist for solar system small bodies. His job involves coordinating observations, understanding what the telescopes are seeing, and translating complex data into coherent narratives. When journalists asked him about Oumuamua, his response was measured but clear. It looks like a comet. It does cometary things. It is very, very similar in most ways to the comets we know. Statler acknowledged that Oumuamua has unusual properties, strange chemistry, an interesting orbit. It is worthy of careful study. But unusual does not mean artificial. Nature is very creative. The universe creates objects that surprise us, that don't fit neatly into existing categories. That's how we learn. That's how science progresses. His argument is basically, yes, it's weird, but weird things happen in nature all the time. And we have no compelling reason to invoke technology where natural processes can explain what we're seeing. The scientific community largely agrees with Statler. When you survey astronomers, when you ask them what they think Oumuamua is, the overwhelming consensus is that it's a comet with some unusual features, perhaps due to quirks in its formation or composition. There's nothing that requires invoking extraterrestrial intelligence, nothing that can't be explained by the physics we already understand. But consensus is not the same as certainty. And there's a difference between explaining something in principle and explaining it in detail. Yes, in principle, a comet could have a forward-pointing jet. In principle, it could show a huge nickel emission without any iron. In principle, it could have a carbon dioxide to water ratio 8 times higher than any comet we've ever seen. In principle, each anomaly has a natural explanation. The question is whether all of those principles. Is it stretched too far when you stack them all together? At what point does it, in principle, become unbelievable? Loeb's response to his critics has been consistent. He welcomes data. He will change his assessment when the evidence warrants it. He has proposed a scale called the Loeb scale, where 0 is certainly natural and 10 is certainly technological. He has placed the Atlas object at different points on that scale as new information has come in. Currently, he says there is a 30 to 40% chance of a non-natural origin. That number outrages his critics. It is not based on rigorous Bayesian analysis. It is not derived from a formal probability model. It is a gut feeling dressed in a quantitative guise. And a gut feeling, no matter how experienced the gut that feels it is, does not constitute scientific evidence. But Loeb argues that his critics are making the same mistake in the opposite direction. They are assigning a near-zero probability to the technological hypothesis without rigorous justification. They are assuming a natural origin because that is the default, because that is what we have always found before. because invoking intelligence feels like giving up on science. He points to the history of the discovery of pulsars. The signals were so regular that astronomers half-jokingly called them LGM-1, LGM-2 little green men. The idea that they might be artificial was briefly considered, then dismissed when a natural explanation emerged: spinning neutron stars at precise intervals. Lighthouse beams sweeping through space. Nature could produce those signals. No intelligence required. But what if nature could not produce the signals? What if no known physical process could explain what was observed? At what point would the scientific community seriously consider the possibility that we have detected technology? And how much evidence would it take before that possibility became the leading hypothesis? Those questions have no clear answers. Science has no protocol for this situation. We have never found artifacts from another civilization. We do not know what the evidence would look like. We do not know how to weigh anomalies against the vastness of the prior probabilities. And so we debate. Loeb, on one side, declaring we should keep an open mind, that dismissing possibilities without investigation is itself unscientific. The mainstream on the other side declaring that extraordinary claims require extraordinary evidence. The evidence so far is interesting, but it is far from extraordinary. The Civil War plays out in papers, blogs, and conference presentations. It plays out in funding decisions, in which proposals get approved, in who gets telescope time for follow-up observations. It plays out in media coverage, in public perception, in whether people trust scientists to tell them the truth about what is happening in their own solar system. And through it all, BAI Atlas continues its journey, indifferent to the debate, following its trajectory, regardless of what humans think of it. The object doesn't care if we call it a comet or a spacecraft. It will do what it is going to do. The data will ultimately settle the argument. Not blog posts, not Twitter threads, not cable news interviews, observations. Measurements of the stubborn facts of what happens when Atlas reaches perihelion, as it emerges from behind the sun and continues its outward journey past Jupiter, and eventually leaves our solar system entirely. Until then, the scientific civil war continues, and the casualties are measured not in ruined careers, but in eroded public trust, in the growing sense that perhaps scientists don't know as much as they claim, that perhaps the experts are too quick to dismiss ideas that threaten their worldview, that perhaps the establishment is more concerned with maintaining consensus than with discovering the truth, that erosion matters. Because if BAI Atlas does turn out to be something unexpected, if evidence emerges that cannot be dismissed or explained away, we will need public faith in our scientific institutions to help process what that means. And right now, that faith is fracturing, breaking along the same lines as the debate itself. Chapter 5. The Mathematics of Impossibility. 4,000 observations. 227 observatories. 5 months of observation. Avi Loeb and his team compiled every available measurement of BAI Atlas's position as it moved across the sky. The data came from professional observatories, amateur astronomers, automated survey systems, anyone who had pointed a telescope at the object and recorded its coordinates. They fed it all into orbit calculation software, the kind that can determine an orbit with extraordinary precision when you have enough data points. What they found was an object following a path shaped purely by gravity. No deviation, no unexplained acceleration, just the elegant mathematics of an object moving through the sun's gravitational field, exactly as Newton's laws predict. That should have settled the question of a natural origin. Case closed. Except for one problem: the object was losing mass. Hubble Space Telescope images from July 21st clearly showed a plume of material extending from B Atlas toward the sun, about 10 times longer than it was wide. Material was being ejected from the sun-facing side, driven off by a combination of sublimation and pressure. When you lose mass in a preferential direction, physics demands that you accelerate in the opposite direction. It's the conservation of momentum. Throw something forward. You move backward. Comets do this all the time. As ice sublimates and gas jets out, the comet experiences a small push, a non-gravitational acceleration that slightly alters its trajectory. Astronomers can measure these accelerations. They're small, but they're real and detectable. When you have enough observations, you see the object deviate from a purely gravitational path. The math shows the deviation. Atlas showed no deviation, no measurable non-gravitational acceleration, despite clear evidence of mass loss. Loeb did the calculation. If the object was losing 150 kilograms per second, which is consistent with what Hubble observed, and if that mass was being ejected in a sunward-facing jet, then the conservation of momentum says the object must be accelerating away from the sun. That acceleration should be detectable in the orbital data. It should show up as a small but measurable change in the trajectory. It didn't. The only way to reconcile these facts is if the object was much more massive than expected. If it were massive enough that 150 kilograms per second was negligible, like throwing a pebble off an aircraft carrier. The ship doesn't slow down because the mass ratio is absurd. How massive would BAI Atlas need to be? For the mass loss to be undetectable, Lepp calculated it. A minimum of 33 billion tons, with a solid rock density of about 2.5 grams per cubic centimeter. That mass is equivalent to a diameter of about 5 kilometers, the width of Manhattan Island. That's not a comet nucleus. That's a small asteroid. Asteroids don't produce jets. They don't push material toward the sun. They are solid rock, not ice. The whole reason we thought Bialas was a comet is because it was doing things that only comets do. So we have an object that behaves like a comet, but needs to have the mass of an asteroid. To explain why its orbit hasn't changed at all, the math doesn't care about our categories. It only requires internal consistency, and right now, the pieces don't fit together neatly. The Spherix Space Observatory complicated things further. Between August 8th and 12th, it collected 10 infrared observations of Baia Atlas, based on its brightness at a 1 micrometer wavelength. Assuming a reasonable albedo, the research team calculated a diameter of 46 kilometers. That is 10 times larger than the minimum mass estimate, if Spherix is correct. Bialas is not just the size of Manhattan, but larger than many asteroids in the main belt. 46 kilometers means a mass of about 1 trillion tons, 1 million times more massive than 2I Borisov. The previous interstellar comet. This creates a statistical nightmare. Interstellar space isn't empty, but it's not exactly crowded either. Based on what we know about star systems, planet formation, and the rate at which objects are ejected into interstellar space, we can estimate the amount of material out there. Per unit volume of rocky objects, icy objects, and various size distributions, the numbers tell us that detecting an interstellar object 46 kilometers in diameter within 10 centuries of survey activity is spectacularly unlikely. We should have found hundreds or thousands of smaller objects first. Comets the size of 2I Borisov should be common. Objects the size of Manhattan should be rare. And objects 50 times larger should be essentially non-existent in the sample we have collected. However, here it is, the third interstellar object ever confirmed, and it was a giant. Loeb had pointed this out in his first paper on BAI Atlas, making the containment argument. If you want to have a 46-kilometer rock sent into the inner solar system every 10 millennia, you need a certain density of such objects in interstellar space. When you calculate that density, it exceeds what star systems can reasonably produce by about 4 orders of magnitude. That is 10,000 times more material, or we were extremely lucky to catch the rare giant on only our 3rd try, or something about our assumptions is wrong, or the object is not a random sample from the interstellar population. Statistics can't prove anything is artificial, but they can tell you when something is surprising. When you flip a coin and get tails 3 times in a row, you don't immediately assume the coin is rigged. But if you flip it 100 times and get tails every time, you start looking very closely at that coin. BAI Atlas is the statistical equivalent of a suspicious coin, with each measurement adding another improbability. Its orbit aligned with the ecliptic plane, rare. The timing of its passage by multiple planets, extremely rare. Its mass far exceeding expectations. Absurd. Its chemistry showing unusual industrial signatures. The unexplained activation during a lunar eclipse. Each one individually could be random. Together, they form a pattern that makes statisticians uncomfortable. And there's one more number in that pile, the most disturbing one of all, the connection to the wow signal. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected a strong, narrow-band signal at a frequency of 1,420.456 megahertz, 72 seconds long, 30 times stronger than the background noise, right on the hydrogen line frequency that SETI researchers consider a universal hailing channel. Astronomer Jerry Eman wrote, "Wow" on the printout. The signal never repeated. The recorded coordinates: right ascension 19 hours, 25 minutes. Declination 27 degrees, in the direction of Sagittarius, toward the galactic center, a crowded region of stars. Loeb calculated where BAI Atlas was on August 15th, 1977. Not where it is now, but where it would have been 48 years ago. By tracing its orbit backward, the object would have been about 600 astronomical units from Earth, still on approach, moving at a characteristic velocity of 60 kilometers per second. Right ascension 1940, declination 19 degrees, with a separation distance of 9 degrees, in a sky with an area of 41,000 square degrees. Two random directions have about a 0.6% chance of being aligned within 9 degrees of each other. It could be a coincidence. The galaxy is full of stars in that direction. The wow signal could have come from any one of those stars, or from none of them at all. If it was some terrestrial interference that somehow bypassed all the filters designed to exclude false positives. But if BiAtlas transmitted that signal 48 years ago, if it was testing Earth's detection capabilities, or announcing its presence, or scanning for radioactivity, then what kind of transmitter would it need? The lab ran the numbers at a distance of 600 astronomical units. Creating a signal strong enough to register at the sensitivity of the Big Ear telescope would require between 0.5 gigawatt and 2 gigawatts of power, which is the power output of a large nuclear reactor. It is within the range of power generation we can conceive of for an advanced spacecraft. Not impossible, not requiring physics we don't understand, just engineering on a scale far beyond what humans have achieved in space. And if the signal was transmitted 48 years ago, from an object that just happens to be passing through our inner solar system right now, that implies timing, planning a trajectory calculated to arrive decades after the initial signal to the target civilization, time to develop detection capabilities, time to realize they are being watched. Or it implies that we are very good at finding patterns in random noise, that it's just close enough to be interesting, but not close enough to be convincing that the whole thing is more than a coincidence, piled on top of coincidence, wrapped in wishful thinking. Mathematics can calculate probabilities. It can tell you what is likely to happen under different assumptions. What it cannot do is tell you which assumption is correct. The numbers show. BAI-Alice is anomalous by many independent metrics. But does that anomaly mean technology or just a rare natural circumstance? Mathematics alone cannot answer. But the numbers keep piling up. A minimum mass of 33 billion tons, a possible diameter of 46 kilometers, 0.6% probability for signal alignment, 0.2% for the ecliptic orbit, 0.005% for the planetary timing, Multiply the small probabilities together, and you get very small probabilities. At some point, very small becomes suspicious. At some point, coincidence demands an explanation. We're not there yet. The scientific community hasn't reached a consensus that something truly unusual is happening. But we are closer than most people realize. A few more unexplained data points, a few more measurements that don't fit the models, and the mathematics of impossibility start to look more like a signal than a coincidence. The question is, what happens when we cross that threshold? When the numbers no longer allow for comfortable explanations? When the improbabilities accumulate beyond what chance can reasonably produce? Do we trust the math? Or do we trust our intuition that the universe doesn't work that way? That aliens don't visit solar systems? That extraordinary claims require extraordinary evidence? Even when the conventional explanations have stopped working, the data doesn't care about our comfort. It just keeps coming, measurement after measurement, building a case that something about BI Atlas doesn't fit the story we want to tell. Chapter 6. What Happens in the Dark. October 29th, 2025. BI Atlas reaches perihelion, its closest approach to the Sun, 1.36 astronomical units, about 203 million kilometers, just inside the orbit of Mars. From Earth's perspective, the object disappears, not because it ceases to exist, but because the Sun is in the way. When you stand on Earth looking out into space, the Sun occupies a region of the sky you cannot observe. This conspiracy theory, I don't blame them. It is a sharp observation. If we cannot distinguish between observable physical objects and sophisticated government diversions, if we attribute scientific analysis to ethnic conspiracies instead of evidence, perhaps we are not ready for contact with advanced intelligence. Perhaps we are still too tribal, too quick to suspect hidden agendas, too unwilling to accept that sometimes a comet is just complex without having to be a hoax. But then there are the theories that are not so easily dismissed. Theories that don't require belief in coordinated hoaxes or ethnic conspiracies. Theories that take the data seriously and extrapolate to strange places. The Oumuamua Communications Network theory started on Reddit, spread to Twitter, eventually making its way into blog posts and YouTube videos. The idea is simple. BI Atlas did not arrive alone. It was communicating with Oumuamua, the first interstellar object that passed through our solar system in 2017 and is now heading back into deep space. According to this theory, the WOW signal was not sent to Earth. It was sent from Oumuamua to BI Atlas, a contact message. Oumuamua performed its reconnaissance, gathered data on the inner solar system, detected Earth's radio emissions, then sent a report back toward the direction from which BI Atlas was approaching. The signal we detected was the leakage, the equivalent of overhearing someone else's phone call. BI Atlas received the message, adjusted its trajectory slightly, subtle enough that we could not detect the maneuver at interstellar distances, aiming for a path that would take it close to Venus, Mars, and Jupiter, 48 years later to conduct a more detailed survey. Based on the information Oumuamua provided, it's creative, it fits the timing, it explains why both objects show anomalous properties, why both defy easy classification. They are not natural comets pretending to be spacecraft. They are spacecraft pretending to be natural comets. The problem is proving it. Oumuamua is gone. Too far and too faint to observe anymore. We cannot go back and check for transmissions we might have missed. We cannot verify if it ever transmitted a signal towards the region where BI Atlas was moving. The theory is consistent with what we know, but it is unverifiable. And unverifiable theories, no matter how elegant, do not constitute science. Then there's the Mars connection. John Brandenburg, a plasma physicist, has for years promoted the idea that Mars was once home to a civilization destroyed in a nuclear catastrophe. He points to isotopic ratios in the Martian atmosphere, to unusual concentrations of xenon and other noble gases, to what he interprets as evidence of large nuclear explosions on the surface. The mainstream scientific community dismisses this. The isotopic ratios have natural explanations related to the solar wind stripping away the atmosphere over billions of years. The surface features that Brandon Burke attributes to nuclear explosions are explained by asteroid impacts and volcanic activity. There is no credible evidence of a past Martian civilization, nuclear or otherwise. But if you accept Brandon Burke's framework, BAI Atlas's close flyby of Mars becomes significant. Why would an interstellar probe choose that particular trajectory? Perhaps it was investigating the remnants of what happened on Mars. Perhaps it was searching for technosignatures for clues about what kind of civilization existed there and what destroyed it. Perhaps BAI Atlas is on an archaeological mission, and we are misinterpreting reconnaissance as a threat. This theory layers speculation on top of speculation. You have to believe in Brandon Burke's nuclear Mars hypothesis, which requires dismissing conventional planetary science. Then, you have to believe BAI Atlas is artificial. Then, you must assume it is more interested in an ancient Martian civilization than the current, active one on Earth. Each assumption reduces the plausibility, but it's the kind of narrative that spreads easily. It connects disparate pieces, creating a larger story, lending meaning where there might only be random chance. Humans are pattern-seeking creatures. We see connections even when none exist. The stealth asteroid spaceship theory came from a reader of Block Lab. A person named Gabo So proposed that advanced civilizations would not build spaceships from scratch. They would repurpose natural objects, hollowing out asteroids, installing propulsion and life support systems, camouflaging the technology beneath a natural layer of rock and ice. This solves several problems at once. You don't need to carry all your shielding mass. The asteroid itself protects you from radiation and impacts. You look natural to any civilization observing you from a distance. Your electromagnetic emissions are hidden. Your thermal signature is shielded by the thermal properties of the rock surrounding your habitat. So points out that humanity has already planned for missions of asteroid mining for a more advanced civilization. This could be standard practice. Why build a ship when you can convert existing space rocks into one? If Bialas were a stealth hybrid system, we would not be able to tell from external observations. It would look like a comet, because it is a comet, just one that has been internally modified. The nickel signature, the unusual chemistry, the mass discrepancy, could all be explained by internal technology disguised as natural processes. It cannot be disproven. Any observation that seems to confirm a natural origin could be interpreted as successful camouflage. Any anomaly could be evidence of hidden technology, an adaptable theory, to fit whatever data we find. That is both its strength and its weakness. A theory that explains everything explains nothing. If you cannot imagine an observation that would prove the idea false, then the idea is not scientific. It is metaphysics. But it's fascinating. It makes you look at Bialas differently, not as a rock that might be technology, but as technology designed to look like a rock. The deception is not about hiding the object's presence. We can see it clearly. The deception is about hiding its nature. The dark matter bubble theory appeared on 4 pages. This should immediately raise skepticism. The claim is that Bialas is not an object at all, but a bubble of dark matter or dark energy left over from the Big Bang. It doesn't reflect sunlight the way normal matter does. It draws energy from other sources. Blue light? 6 is the interaction of dark energy with normal space. This theory has the merit of being completely wrong, in interesting ways. It gets wrong what dark matter is, how it works, what the Big Bang created. It is not even wrong in the sense that it is too incoherent to be properly tested, but it still spreads through fringe websites, creating YouTube videos with ominous music and dramatic narration. The fact that it is nonsense has not stopped people from believing in it, because it offers an explanation that feels scientific without requiring any actual understanding of science. Dark matter is a mystery. The Big Bang is a mystery. By Atlas is a mystery. Connect the mysteries, and you get an answer that satisfies the need for meaning without the effort of rigorous thought. The 4-page theory aside, there is one more theory that deserves attention. A decoy within a decoy. This one comes from Oumuamua, and it is recursive in a way that makes your head hurt. What if by Atlas is not the misdirection? What if the debate about by Atlas is the misdirection, while astronomers argue about whether it is natural or artificial, while the public obsesses over alien motherships and government cover-ups? While resources are poured into observing this one object, something else entirely is happening that we are not noticing. Perhaps the real thing actually happened years ago. Perhaps Oumuamua was enough. Perhaps by Atlas is just theatrics, designed to keep us looking at the obvious, while the real action takes place in complete obscurity. It is paranoia nested within paranoia, but it raises an uncomfortable point. How would we know if a sufficiently advanced intelligence wanted to observe us without being detected, wanted to deploy assets throughout the solar system without triggering awareness? How would they do it? They would give us something obvious to obsess over. They would ensure we exhaust our attention on the misdirection, while missing the substance. And the beautiful part from a strategic perspective is that proposing this possibility makes you sound insane. So, even if it were true, even if that is exactly what is happening, anyone who suggested it was dismissed as a conspiracy theorist, a self-protective strategy. Perhaps that is the real intelligence test. Not whether we can detect the obvious, but whether we can maintain enough skepticism about the obvious to notice what is hidden right beside it. Chapter 8. Pascal's Wager for the Apocalypse. Blaise Pascal was a 17th-century mathematician and philosopher who gave us a famous argument for God, the wager. It goes like this. If God exists and you believe, you gain an infinite reward. If God exists and you do not believe, you face infinite punishment. If God does not exist, your belief or disbelief has finite consequences either way. Therefore, rational self-interest demands belief, because the infinite stakes outweigh any finite calculation. The logic is questionable. Many philosophers have spent centuries dissecting it, but the underlying principle is that you should seriously consider any scenario with catastrophic consequences, even if the probability seems low. That principle has applications beyond theology, even if the chance of a technological origin is small, even if 99% of the evidence points to a natural explanation. The implications of that remaining 1% are so severe that we cannot afford to ignore the possibility. We must prepare for the black swan event, the low probability scenario, high impact, that destroys civilizations caught unprepared. There is no playbook for this, no emergency response plan for discovering alien technology operating in your solar system. NASA has protocols for asteroid deflection, plans for how to respond if we detect a collision threat in advance. Those plans assume physics we understand, objects following predictable trajectories, challenges we can model and prepare for. They do not assume intelligence. They do not assume an object that can maneuver, that can deploy assets, that might have intentions we cannot anticipate. The entire framework of planetary defense is built around natural threats, rocks tumbling through space according to the laws of gravity. BAE Atlas shatters that framework, not because it is definitively artificial, but because we cannot definitively rule out that possibility. And the uncertainty of intent is far more dangerous than the certainty of random celestial mechanics. Loeb wrote a white paper addressed to the United Nations to present it in late September 2025, the day before the Mars flyby. The document proposes the establishment of an international committee tasked with monitoring and analyzing interstellar objects in search of potential technosignatures, a coordinated effort to assess anomalies, share data across national borders, and develop response protocols for scenarios we hope will never occur. The paper makes the case clearly. As the Vera Rubin Observatory begins operations this year, it is expected to detect dozens to hundreds of interstellar objects over the next 10 decades. BAI Atlas is just the beginning. Many more will come. Some will be rocky, some will be comets. And statistically, if the dark forest hypothesis holds any merit, if advanced civilizations are sending probes throughout the galaxy, some of those objects might be exactly that. We need the infrastructure to identify which of these objects require closer scrutiny. Additionally, we need agreed-upon criteria for escalating interest, to trigger further investigation, and to determine when an object's behavior goes beyond natural explanation. We need this in place before a crisis, not in the middle of one. The United Nations has not responded publicly. International committees move slowly. Proposals get buried in bureaucracy, tabled for further discussion, lost in the noise of competing priorities. A white paper from an astrophysicist, no matter how prestigious, does not automatically trigger institutional action. But the absence of a response creates its own kind of vulnerability. Right now, if BAI Atlas were to exhibit unambiguous technological behavior, if it transmitted a signal or maneuvered toward Earth or deployed visible probes, there is no coordinated mechanism in place to decide what to do next. Individual nations would respond based on their own interests, assessing their own threats and their own capabilities. That fragmentation could be catastrophic, with military responses lacking diplomatic coordination, competing narratives about what the object is and what it wants, and decisions driven by panic based on incomplete information. The scenarios that keep people awake at night are not the ones where we respond perfectly to a clear threat. They are the scenarios where confusion and misinformation turn manageable situations into disasters. The dark forest hypothesis provides a framework for thinking about this. The name comes from a science fiction novel by Cixin Liu, but the concept is older. If the universe contains many civilizations, and if resources are finite, and if you cannot know the intentions of others until it is too late to defend yourself, then the optimal strategy is to remain silent and to preemptively eliminate potential threats. Civilizations that announce their presence will be destroyed. The surviving civilizations are those that keep themselves hidden, those that strike before they encounter others, those that never take risks with unknown intelligences. The galaxy becomes a dark forest, where every civilization is a hunter, and every sound in the dark could be another hunter preparing to fire. Under this framework, the arrival of Biolas to our solar system is not a friendly visit. It is reconnaissance before elimination, the object collecting data on our defensive capabilities, our technological level, when it has what it needs, when it determines whether we pose a future threat. It or other objects like it will act. If you believe in the dark forest hypothesis, Pascal's wager becomes even more stark. The downside of ignoring potential alien technology is not just missing a chance for contact, it is extinction. You do not get a second try when you are dead. But the dark forest is only one possibility among many. Other frameworks exist. Perhaps advanced civilizations are benevolent, interested in helping younger species develop. Perhaps they are indifferent, pursuing their own goals without regard for primitive cultures like our own. Perhaps they are scientific, studying us the way we study in colonies, with curiosity but no moral weight. We do not know. We have no examples of alien civilizations to reference. All of our frameworks are speculation, thought experiments, extrapolations from human behavior, which may not apply to minds formed by entirely different evolutionary pressures. That uncertainty is what makes it so difficult to plan a response. It becomes difficult. You cannot defend against unknown threats. You cannot negotiate with intentions you cannot predict. You cannot prepare for scenarios when the scenario space is completely infinite. So what can we do? Loeb's answer is twofold. First, gather observational data as thoroughly as possible. Monitor any behavior that definitively rules out a natural explanation. If it maneuvers, if it changes course, if it deploys anything, document it immediately. Evidence removes uncertainty. Second, build redundancy into observational systems. Do not rely on a few large telescopes that might be offline when something important happens. Distribute capabilities. The Galileo project's approach, many small observatories continuously monitoring the entire sky, creating resilience if something unusual occurs. Multiple independent systems will collect it. The data cannot be suppressed or dismissed as an equipment malfunction. Loeb also advocates for transparency. Whatever we discover, share it publicly. Do not classify information. Do not restrict access. Do not let governments monopolize knowledge of potential extraterrestrial technology. The more people who have the data, the harder it is to control the narrative. The more likely it is that someone will notice patterns that official channels miss. This position is controversial. The intelligence and defense communities prefer control. They want time to assess threats before public awareness causes panic. They want operational security, the ability to plan a response without broadcasting intentions. Transparency sounds noble, but it complicates strategy. But Loeb argues that secrecy creates worse problems if governments hide evidence of extraterrestrial technology. If only classified channels have access to the data, then public trust will collapse when the truth inevitably leaks, and it always leaks. Secrecy on this scale cannot be contained indefinitely. Someone talks, someone shares, and when they do, the revelation is worse because it confirms every conspiracy theory about government deception. It is better to face the truth collectively, to process the implications together, rather than pretending we can manage knowledge on behalf of populations kept in ignorance. Adults can handle difficult realities. What they cannot handle is discovering they have been lied to about the most important question that humanity has ever faced. Are we alone if Atlas is natural? If it is just an unusually interesting comet, then none of this matters. The protocols are not enacted. The committees are not formed. We file this experience away as a reminder that nature creates the unexpected, and we move on. But if there is even a small chance that we are wrong, if the anomalies point to something that we are not yet ready to admit, then Pascal's wager applies. The cost of preparing, of seriously considering the possibility of building infrastructure to detect and respond to extraterrestrial technology, that cost is finite. The cost of ignoring the threat and being wrong is extinction. When you frame it that way, when you admit that we are gambling with the survival of our civilization, the math becomes simple. You prepare for the worst, even while hoping for the best. You build the systems that can save you, even if you never need them. You seriously consider the long shot, because the downside of dismissing it is permanent. Atlas is either a comet or it is something else. By the end of December, we will have better data, new observations post-perihelion, orbital calculations, accounting for any changes, chemical analysis. As the object becomes active, moving outward, the data will narrow the possibilities. Perhaps it will resolve the question entirely. Perhaps we will finally have enough evidence to say definitively that this is natural, that all the anomalies have an explanation, that we were pattern matching on noise rather than signal. Or perhaps the data will deepen the mystery. Perhaps we will find new anomalies, additional deviations from expectation, evidence that pushes against the comfortable interpretation. Perhaps we will cross a threshold where the natural explanation ceases to be sufficient, where the weight of accumulating improbabilities forces us to consider the alternatives we have been avoiding. Either way, Pascal's wager suggests we should be ready, because betting wrong on this question means there is no one left to learn from the mistake. Part 2. Let's talk about the latest science and space news. 3 days ago, something happened at NASA. I do not want you to panic about it while you are sleeping. An asteroid the size of a school bus passed closer to Earth than the satellites that are beaming this video to your screen right now. We did not even see it coming until it was already gone. But that is not the reason I'm recording this at 3 in the morning, literally with trembling hands. In the last 72 hours, we have had Pentagon whistleblowers swearing under oath about UFOs that can withstand direct missile strikes, NASA quietly confirming the strongest evidence of ancient life on Mars they have ever seen, and multiple astronomers are now openly discussing why extraterrestrial civilizations might be deliberately hiding from us in what they call the dark forest, where revealing yourself means immediate annihilation, and this is the part that should terrify you. All of this is happening while China and NASA are in a desperate race to claim the moon's most valuable real estate, because whoever gets there first could control humanity's future in space forever. What you are about to hear may be the most important space update you will ever watch, because if even half of what is being revealed this week is true, everything is about to change before we dive into what NASA just admitted about Mars. Please hit that like button and subscribe if you want to be notified about these cosmic revelations. And let me know in the comments where you are listening from, what time it is where you are, and whether you think we should continue broadcasting our location to the cosmos or go silent immediately. Share this on X, Facebook, Reddit, or your messenger to help our community grow. Thank you for your continued support. Chapter 9, The Mars Bombshell. In the next part of the talk, we have an object that behaves like a comet, but needs to have the mass of an asteroid to explain why its orbit has not changed at all. Ancient life has finally been confirmed. Let me tell you about a rock that is keeping planetary scientists up at night, not because of what it is, but because of what it means. For everything we ever thought we knew about life in the universe, on July 21st, 2024, NASA's Perseverance rover was making its way across an ancient riverbed in Mars' Jezero crater when its cameras locked onto something that made mission control go silent. Picture this, a 3-billion-year-old rock, nicknamed Chaffos, with suspiciously familiar-looking patterns, familiar to anyone who has studied ancient life on Earth. They call them leopard spots, dark rings with lighter centers scattered across the rock's surface like natural Morse code. Now, you might be thinking, so what? It's just a spotty rock. But this is where it gets interesting. These aren't random patterns. When Perseverance aimed its PXL instrument at those spots, the data that came back, well, let's just say it made some very serious scientists start reconsidering their retirement plans. The dark rims of these leopard spots are rich in iron phosphate, specifically a mineral called vivianite. The lighter cores contain iron sulfide, likely greigite. If those names don't mean much to you, let me put it this way. On Earth, when we find these exact minerals together in ancient rocks, arranged in these exact patterns, there's usually only one explanation: microbes, ancient bacteria that once lived, breathed, and died in that mud, leaving behind these chemical signatures like tiny tombstones marking their existence. Think about that for a moment. We could be looking at evidence of organisms that lived on another planet before life on Earth had even figured out how to build a proper cell membrane. The Bright Angel Formation, where this rock was found, tells a story like a murder mystery written in stone from 3.5 billion years ago. This wasn't the rusty desert we see today. It was a lake, possibly warm, definitely wet, with water flowing in from river channels that had carved their way through the crater walls. The sediments that settled at the bottom of that lake became the mudstone we're examining today. And trapped inside that mudstone are organic carbon, sulfides, and phosphorus, all the ingredients you need for a microbial dinner party. But this is where NASA's announcement gets really interesting, and why they spent over 1 year peer-reviewing it before going public. The arrangement of these minerals suggests something called a redox reaction. chemical processes where electrons are passed back and forth like currency in a microbial economy here on Earth. These reactions are often driven by life, as bacteria use them to generate energy, like tiny biological batteries, powering themselves with chemical gradients. The specific combination found in Cha Falls, oxidized iron here, reduced sulfide there, with organics playing the role of mediator, is exactly what we would expect if ancient Martian microbes were conducting their own version of cellular respiration. The lead author of the study, which was just published in the journal Nature, put it brilliantly. He said that they're seeing evidence of chemical reactions that on Earth are typically mediated by biology, not definitively biological, mind you, but typically biological. The word typically is doing a lot of heavy lifting here, because it represents both the excitement and the frustration of this discovery. We can't prove these patterns were created by life, not yet. There are abiotic processes capable of producing similar features, though when the research team examined those alternatives, none of them really fit. High temperatures could create some of these minerals, but the rock shows no signs of ever having been cooked. Acidic conditions might work, but again, there's no evidence. It's like finding footprints in your backyard. Theoretically, they could have been made by something other than feet, but at some point, you have to consider the obvious explanation. What makes this discovery even more significant is where it fits into the Martian timeline. Previously, scientists thought that if life ever existed on Mars, it would have been confined to the planet's very earliest days, back when it still had a thick atmosphere and a magnetic field. But the Bright Angel Formation is younger than that, much younger. It suggests that even after Mars had lost most of its protective atmosphere, even after the planet had begun its transformation into the frozen desert that we see today. There were still small pockets where life could have persisted, oases in an increasingly hostile world. The implications extend far beyond Mars. If life arose independently on two planets in the same solar system, what does that say about the rest of the universe? We would be looking at evidence that life isn't some cosmic fluke, but rather an inevitable consequence of chemistry and the right conditions. Or, and this is where things get a little unsettling, what if life didn't arise independently on both worlds? What if it traveled between them, hitching a ride on meteorites blasted into space by ancient impacts? We know rocks can make that journey. We found Martian meteorites here on Earth. Could life have made the same trip? These questions aren't just academic curiosities anymore. NASA is already planning how to bring these samples back to Earth, where they can be studied with instruments far more sophisticated than anything we could ever send to Mars. The Sapphire Canyon sample that Perseverance drilled from Father's Falls is sitting in a sealed tube right now, waiting for a future mission to retrieve it and bring it home. When that happens, and we're talking about the 2030s, if everything goes according to plan, we might finally be able to answer the question that has haunted humanity ever since we first looked up at that red dot in the night sky. Have we ever been alone? But while NASA focuses on ancient dead microbes, something far more immediate and potentially more dangerous has been unfolding right here on Earth. Longtime whistleblowers are coming forward with claims that make the discoveries on Mars look like child's play, because according to their testimony, we aren't just dealing with ancient fossils. We're dealing with technology that shouldn't exist, objects that defy our understanding of physics, and a government cover-up that goes deeper than anyone imagined. The veil of secrecy is finally beginning to lift, and what lies beneath will change everything you thought you knew about our place in the universe. Chapter 10. The UFO Disclosure Crisis. The Pentagon whistleblowers make their stand. Picture the scene. On September 9th, 2025, inside a congressional hearing room packed with military veterans with decades of combined service. They are raising their right hands to be sworn in. They are about to testify about something that could end their careers and ruin their reputations and potentially put them in legal jeopardy, but they are doing it anyway. because what they have seen, what they know, is too important to keep secret any longer. The first witness to speak is Dylan Bolin, an Air Force veteran who worked at Langley Air Force Base in Virginia. His voice is steady, but you can hear the weight of what he is about to say. In December of 2023, he witnessed something the Pentagon desperately wanted to keep hidden: multiple unidentified aerial phenomena, what we used to call UFOs. Before the government rebranding, they were hovering over one of America's most secure military installations, not for a few minutes, but for weeks. These were not distant lights or fuzzy radar blips. These were clearly defined objects, defying everything we know about aerodynamics, hovering in restricted airspace as if they owned the place. But this is where Bolin's testimony took a turn that had everyone in that hearing room leaning forward. When he reported these sightings through official channels, when he did exactly what military protocol required, he was met with something worse than skepticism. He was blacklisted. His security clearance was threatened, and job opportunities with federal intelligence agencies suddenly vanished. The message was clear: keep quiet, or we will ruin your life. Think about that for a moment. A decorated military veteran sees a potential threat to national security, reports it through the proper channels, and instead of being thanked, he is punished. What does that say about what is really going on here? Either our government is spectacularly incompetent at handling real security threats, or they know exactly what these objects are, and they are terrified of that information becoming public. Then, Representative Eric Burles from Missouri did something that no one expected. He showed a video, not some vague, blurry footage. That could have been anything from a weather balloon to a bird. This was military-grade footage from an MQ-9 drone, an MQ-9 Reaper operating off the coast of Yemen in October 2024. The room fell silent as they watched a perfectly spherical orb move at an impossible speed across the screen. Then came the moment that defied explanation. The Reaper fired a Hellfire missile. The Hellfire hit the object, a direct hit, the explosion filling the screen. And when the smoke cleared, the orb was still there, completely unaffected, continuing on its path as if nothing had happened. Let that sink in. A Hellfire missile is designed to destroy tanks and bunkers. It had no effect on this thing, the same weapon that has been the backbone of American military superiority. For decades, might as well have been a water balloon. Balest's question to the panel was simple yet devastating. Why were we blocked from this information? What else has been hidden from Congress, from the American people, from the world, the All-Domain Anomaly Resolution Office, the Pentagon's AARO, the organization supposedly created to investigate these phenomena with transparency and scientific rigor, was revealed to be anything but. Witness after witness described how ARO dismissed cases without proper investigation, ignored compelling evidence, and seemed more interested in debunking than discovery. Jeffrey Nucatelli, another Air Force veteran on the panel, described ARO's approach as using science to come up with answers that fit their predetermined conclusions, rather than following the evidence wherever it led. But the real bombshell came when journalist Josh Knapp took the microphone. Knapp had been investigating UAPs for over 3 decades, and he dropped a piece of information that sent shockwaves through the defense community. According to multiple sources, there is a secret Pentagon program called Immaculate Constellation. The name alone is enough to send a chill down your spine. This is not a regular classification. This is a special access program so secret that most members of Congress do not even know it exists. And what is Immaculate Constellation allegedly doing collecting and analyzing UAP encounters that are too sensitive, too paradigm-shifting to be processed through normal channels? The Pentagon's reaction was swift and predictable. They claimed no knowledge of any program by that name. But here is the thing about classified programs. They are designed to be deniable. That is the entire point. The people denying it might not even know it exists. Or worse, They know exactly what it is, and they are lying to your face, confident that the classification system will protect them from being held accountable. What makes this testimony particularly compelling is the caliber of the witnesses. These are not conspiracy theorists broadcasting from their basements. We are talking about high-ranking military personnel, people with top-secret clearances, individuals who have dedicated their lives to serving and protecting this country. When they risk everything to come forward, when they face the possibility of prosecution under the Espionage Act just to tell the truth, perhaps we should listen. The proposed UAP Whistleblower Protection Act, introduced by Representatives Tim Burchett and Anna Paulina Luna, represents a significant turning point. For the first time, there will be legal protection for those who bring forth information about these programs. Think about what that implies. Congress feels the need to create special legislation just to protect those who want to tell the truth about what they have seen in our skies. That is not normal. That is not how a transparent democracy is supposed to function. A senior chief petty officer, Alexandro Wiggins of the Navy, provided perhaps the most chilling testimony of all. He described encounters with objects that demonstrated capabilities we cannot even theoretically explain. Instantaneous acceleration from a hover to hypersonic speeds, making right-angled turns at velocities that should have torn apart any known material, the ability to operate seamlessly in the air, water, and space without any visible means of propulsion. These are not just advanced aircraft. These are technologies that seem to operate on entirely different principles of physics. The implications are staggering if this is a foreign adversary. Then, America has lost its technological superiority, and we just do not know it yet. If there is a secret American program, then we are dealing with a breakaway civilization within our own government. Of ours operates with technology that is decades or centuries ahead of what the public knows. And if there is something else, something not from Earth, then every assumption about our place in the universe needs to be reconsidered. Joe Spielberger from the Government Oversight Project made an important point in his testimony. This isn't just about UFOs. This is about government accountability, constitutional oversight, and the fundamental principle that in a democracy, the people have a right to know what their government is doing. When you have programs so secret that even Congress cannot access them, when you have military personnel being threatened for reporting potential security threats, when you have evidence being systematically concealed or destroyed, you no longer have a democracy. You have something else entirely. The pattern is becoming impossible to ignore. Witness after witness, incident after incident. The evidence keeps piling up. And it's not just American military personnel. Similar testimonies are coming from Canada, Brazil, Japan, and France. Either we are dealing with a massive, coordinated delusion affecting trained observers across the globe, or something truly extraordinary is happening in our skies. But while Congress fights for disclosure and whistleblowers risk everything to reveal the truth, a darker possibility lurks in the shadows of scientific theory. What if the reason for all this secrecy isn't to hide the existence of aliens, but to hide the reason why they keep themselves hidden from us? What if Earth has already been discovered by civilizations that see our emergence into space not as a welcome development, but as a threat to be eliminated? The universe may be far more dangerous than we ever imagined, and we may have already made a fatal mistake. Chapter 11. The Dark Forest Warning. Why might aliens be hiding? Imagine you are walking through a pitch-black forest at night. You can't see more than a few feet ahead of you. In every direction, you know there are others in this forest, hunters just like you, armed and dangerous, where every sound could be a threat, every movement could reveal your position. And the only way to survive is to remain absolutely silent. Because the moment you reveal yourself, the moment you make a sound, you become a target. This is the universe according to the dark forest theory, and it might explain why the universe seems strangely silent. Despite the mathematical certainty that we are not alone, this theory gained public attention through the science fiction trilogy by Chinese author Cixin Liu. But its origins run deeper into game theory, evolutionary psychology, and the cold mathematics of survival. Here's the chilling logic. Every civilization wants to survive. There is no way to know if another civilization is hostile or peaceful. Even if they seem peaceful now, they could become hostile later. The safest choice is to destroy any civilization you detect before they have a chance to destroy you. Therefore, all intelligent civilizations keep themselves hidden, and any civilization that reveals itself is immediately eliminated. Dr. David Brin, a renowned astrophysicist, helped develop this concept before Lu popularized it. He put it even more starkly, suggesting that somewhere in our galaxy there might be ancient machines, berserker probes, as he called them, left behind by long-dead civilizations. Their sole purpose is to detect and destroy any new intelligence that emerges. One broadcast, one signal reaching the wrong ears, or rather, the wrong sensors, and Earth would receive a visit from something that makes our nuclear weapons look like firecrackers. Consider what humanity has been doing for over a century. We have been shouting into the void, with radio broadcasts, television signals, and military radar, all spreading outward in an expanding sphere of electromagnetic radiation, which now envelops thousands of star systems. We are like children playing with matches in a dark warehouse full of explosives, completely unaware of the danger we might be attracting. That sphere of signals, moving at the speed of light, has already reached stars like Wolf 359, Ross 128, and Luyten's star. If anything intelligent lives in those systems, they know we are here, but it gets worse. In 1974, we deliberately sent the Arecibo message towards the M13 globular cluster, a dense ball of stars about 25,000 light-years away. This was not random noise. It was a deliberate shout into the dark, complete with information about our biology, our solar system, and even our DNA structure. Carl Sagan called it a cosmic calling card. Others might call it a suicide note. And it certainly will not reach its destination for thousands of years. But that message, that deliberate announcement of our existence, is irrevocable, unstoppable, hurtling through space like a cosmic confession. The mathematics of detection make the situation even more precarious. Dr. Jason Wright from Pennsylvania State University calculated that any civilization just 1,000 years more advanced than us could detect Earth's biosignatures from hundreds of light-years away. The oxygen in our atmosphere, the methane from our agriculture, the industrial pollutants we have pumped into the air. All of this creates a spectral fingerprint that screams inhabited planet. For anyone with a decent telescope, we are not just broadcasting our existence via radio waves. Our planet itself is a beacon. Stephen Hawking, shortly before he died, warned against actively trying to contact alien civilizations. His reasoning was simple and chilling. Look at what happened when European explorers met less technologically advanced civilizations here on Earth. The results were catastrophic for the indigenous populations. Now imagine that technological gap multiplied by thousands or millions of years. We would not be conquered. We would be stepped on like ants, perhaps without the superior civilization even noticing. The Fermi paradox suddenly becomes terrifyingly logical through this lens. We do not see evidence of alien civilizations, not because they do not exist, but because the ones that revealed themselves were eliminated, and the ones that survived have learned to hide. The great silence is not emptiness, it is fear. Every intelligent species discovers radio astronomy, also discovered the game theory that says to remain silent or die, except for us. Dr. Alexander Berezin from Russia's National Research University of Electronic Technology proposed an even darker variation. What if the first civilization to achieve interstellar capability inevitably destroys all other civilizations? Not out of malice, but because of simple expansion, like a bacterial colony consuming all available resources in a petri dish. They might not even notice the lesser civilizations they are destroying. We could be destroyed not by a deliberate attack, but as collateral damage from someone else's growth. The recent UAP revelations take on a different character when viewed through the lens of the dark forest. What if these objects aren't visitors, but scouts? What if they aren't here to communicate, but to assess whether we pose a threat? The fact that they seem particularly interested in our military and nuclear facilities is not at all reassuring. They are examining our weapons, assessing our capabilities, determining whether we need to be dealt with now or can be safely ignored for a few more decades. There's a chilling consistency with the timeline. UFO sightings exploded after we detonated the first atomic bomb. It's as if crossing the nuclear threshold triggered some kind of monitoring protocol. We announced to the universe that we had figured out how to split the atom, and suddenly things started showing up to watch us. Perhaps they aren't here to invade. Perhaps they are here to decide if we need to be preemptively eliminated before we become a real threat. Game theory supports this paranoid interpretation in the so-called prisoner's dilemma. With infinite stakes, the rational choice is always to defect, to strike first. Cooperation only works if you can guarantee repeated interactions and mutual benefit. But when the stakes are species survival and you can't verify the other player's intentions, the math says, destroy them before they destroy you. It's not evil, it's rational. It gets worse. Some scientists argue that we are already past the point, cannot go back. Dr. Eugene Tucker calls it cosmic pessimism. Cosmic pessimism. The realization that we have revealed ourselves and now we are just waiting to see if something responds. Every year that passes without contact could mean we are alone, or it could mean that something is already on its way, moving at a fraction of the speed of light, arriving in decades or centuries with capabilities we cannot imagine and intentions we dare not contemplate. The dark forest theory also explains why SETI has found nothing despite decades of searching. We are searching for signals from civilizations broadcasting their presence. But if the theory is correct, anyone intelligent enough to develop radio is also intelligent enough to stop using it immediately once they realize the implications. We are looking for the cosmic equivalent of dead civilizations. Civilizations that didn't figure out the game in time, but there is a group that claims to know exactly why the silence is about to break, why the dark forest may be about to ignite with the light of open warfare. According to their interpretation of recent events, Earth and the Moon are about to become a battlefield for competing civilizations, and the race between NASA and China is not about national pride or scientific achievement. It's about claiming the strategic high ground before the real conflict begins. Chapter 12. The Moon Race Heats Up. The Secret Agendas of China and NASA. Last week, Bill Nelson, the acting administrator of NASA, stood before a room full of space agency employees, his face flushed with anger, barely contained. "I'll be damned if that's the story we write," he said, his voice echoing through the silent auditorium. "We are going to beat the Chinese to the moon. We are going to do it safely, quickly, and correctly." This was not just another pep talk. This was a declaration of war, a space war that most people didn't even realize was being fought. The stakes could not be higher. Whoever plants their flag at the lunar South Pole first doesn't just win a symbolic victory. They potentially control access to billions of tons of water ice, the key to everything from drinking water to rocket fuel. They set the standards for communication that everyone else will have to follow. They write the rules for lunar traffic management, resource extraction, and territorial claims. In essence, they become the gatekeepers for humanity's expansion into the solar system. Former NASA administrator Jim Bridenstine dropped a bombshell in recent Senate testimony, which should have sent shockwaves around the world, but was somehow buried in the news cycle. He stated it is highly unlikely the United States will return humans to the moon before China plants its flag on lunar soil. Think about that. The nation that won the first space race. The nation that put 12 men on the moon. is about to lose the second space race to a country that didn't even have a space program 55 years ago. The problem, according to Bridenstine, is not technology or funding. It is the architecture. NASA has chosen SpaceX's Starship as their lunar lander, a vehicle that requires an unspecified number of refueling launches just to get to the moon. No one has ever attempted orbital refueling on this scale. It's like planning to cross the Atlantic Ocean by building your airplane in mid-air. Meanwhile, China is using proven technology, incremental advancements, steady progress. They are not trying to revolutionize space travel. They are trying to win. But there is something else going on here, something that neither NASA nor China is talking about publicly. The urgency of this race doesn't align with the stated goals of scientific research and national prestige. Both superpowers are pouring resources into their lunar programs at a rate that suggests they know something we don't, or rather, they know something they are not telling us. Consider the specific locations they are targeting the lunar South Pole. Not just valuable for its water ice, it contains peaks of eternal light, 9 mountaintops that receive near-constant sunlight, perfect for solar power generation. But more importantly, these locations offer something else, an unobstructed view of deep space and protective terrain for defensive positions. Military strategists call them key terrain, the high ground that controls everything around it. Whoever holds these positions could theoretically deny access to anyone else. China's Chang'e program has been mapping the far side of the moon, methodically for many years. Their rovers have detected structures 304.8 meters beneath the surface, vast cave systems that could serve as natural shelters from radiation and micrometeorites. But these caves could serve another purpose. They could conceal installations or activities that Earth-based telescopes could never detect. The far side of the moon is the only place in the Earth-Moon system completely shielded from our planet's radio emissions. It is the perfect location to listen into deep space, or to conduct activities that you do not want anyone to know about. The International Lunar Research Station that China is building with Russia and 17 other partners is not just a scientific outpost. The plans include military communication satellites, defense systems, and what they euphemistically call situational awareness capabilities. In other words, the ability to monitor and potentially interfere with anyone else's lunar activities. They are not building a research station. They are building a fortress. The Artemis Base. NASA's Artemis Base Camp sounds civilian and scientific, but look closer at the partners involved. The Department of Defense, the National Reconnaissance Office, the Space Force. These are not organizations interested in collecting moon rocks. They are interested in maintaining American dominance in what they internally call the ultimate high ground. Leaked documents indicate the base will include capabilities to monitor cislunar space, the region between the Earth and the Moon, which is becoming increasingly critical for both commercial and military operations. The timeline is everything. China has announced it will land astronauts on the Moon before 2030. NASA keeps pushing back its dates, currently targeting no earlier than 2027 for Artemis 3. But here is what is really interesting. Both programs suddenly accelerated after 2019. The same year that multiple governments privately briefed their space agencies on something detected on the lunar surface. The briefings remain classified, but the subsequent budget allocations told their own story. Billions of dollars were approved without the usual congressional battles to fast-track the development of LunaNet, the lunar internet. NASA's proposed network was not just about helping astronauts send emails home. It was a positioning and navigation system that would provide American forces with precise location data for any operations on or around the Moon. China's alternative system was anchored by the Queqiao relay satellites, which would serve the same purpose. Whoever controlled the lunar GPS would control movement on the Moon. It was like owning all the maps in a new world. The resource extraction agreements being negotiated right now would determine who got rich and who got left behind. Helium-3, rare earth elements, platinum group metals. The moon held resources worth quadrillions of dollars, quintillions, but more importantly, it held the resources needed to build in-space infrastructure without the enormous cost of launching everything from Earth. The first nation to establish processing facilities on the moon could have an insurmountable advantage in colonizing the solar system. There was another factor that no one wanted to discuss publicly. The moon was the perfect platform for weapons. That could hold the Earth hostage. A mass driver on the moon could launch objects at Earth with devastating force. Lasers based on the moon could target satellites, spacecraft, or even ground installations without atmospheric interference. The Outer Space Treaty was supposed to prohibit weapons on the moon, but treaties are only as strong as the will to enforce them. And who would enforce anything against whoever controlled the high ground? Former NASA scientist or David Livingston calculated that whoever established a permanent base, first on the moon, could potentially claim de facto sovereignty over vast areas simply by being there. Possession is 9/10 of the law on Earth, and in space, it might be 10/10. The Antarctic model of international cooperation sounded nice, but Antarctica has no resources worth fighting for. The moon does. China's mission profiles include something called in situ resource utilization right from day one. They are not planning to visit the moon. They are planning to live off the land immediately. Their first cruise will begin processing lunar regolith into building materials, extracting water, and producing fuel. NASA's plans are more ambitious, but less practical, requiring multiple missions before establishing any real infrastructure. It's the difference between showing up with a tent and showing up with a factory.